they give us the information from 0 to 12. The particle moves along the x-axis. The velocity of the particle at time t is given vt equals cosine pi 6 times t. The particle has a position x equals -2 at time 0. So for part A, it says from this from 0 to 12, when is the particle moving to the left? Well, we know the particle is moving to the left when velocity is negative. So what you have to do is you simply either plug in all the values or just plug it in the calculator and find out when on the graph are the values negative for this equation of velocity, and that was found to be from 3 to 9 is when velocity is negative.
Everybody good with that? Alright. So part B says write, but do not evaluate an integral expression that gives the total distance traveled by the particle from time t equals 0 to time t equals 6. So since basically this one's just kind of picking apart the words they use, so we have to write an integral of the total distance. Total distance should hint that we have to use the absolute value. So we take the absolute value of the integral from 0 to 6. Because we were given the time t equals 0 to t equals 6 of v of t. And that's all you have to do. V.
For part C, it says find the acceleration of the particle at time t. Is the speed of the particle increasing, decreasing, or neither at time t equals 4? Well, acceleration is the derivative of velocity, so you have to take the derivative from the velocity equation and find the equation for acceleration.
Sorry.
Then you graph that. The derivative, the equation for acceleration would be negative sine pi 6. Acceleration. Negative sine pi 6 t times 6. Afterwards, you graph that and you look at where t is, find the values, and see if it's increasing or decreasing on either side of 4. And now Stephanie will explain the concept behind it.
All right. Well, explaining the reasoning is it's increasing at t equals 4 because the acceleration and speed have the same sign. So because when you do like a sign chart, it is negative as it approaches 4 and negative after it gets away from 4. Yeah. They have the same sign, so it is increasing.
Speed is increasing.
And then for part B, it says find the position of particle at t equals 4. So, when time is equal to 4, we have to take the integral from 0 to 4 of cosine pi 6t dt, but we have to add a negative 2 to that because we use 0 is the particles at x equals negative 2. So we have to add the starting position because if we don't have the starting position, we don't know the area we're taking with the integral.
Yeah.
So then we can move the negative 2 outside of the integral because it is a constant. And then we take the antiderivative of the cosine pi 6t. You want what? Instead of trying to do that all at once. And then because it's a definite integral, we just plug in the b value where t is minus the a value where the t is, which is negative 2 plus 6 over pi times square root of 3 over 2. And that is the position when t equals 4.